Welcome to Understand the Math. In this video, we'll walk through how to use the Rational Zeros Theorem to find the rational zeros of a polynomial, especially those with higher degrees where factoring isn't immediately obvious. I'll show you step by step how to list all possible rational zeros, test them using synthetic division, and factor the polynomial completely. We'll work through these two examples together. Let's get started. The Rational Zeros Theorem is used to find the possible rational zeros of a polynomial with integer coefficients. If we have a polynomial f of x written like this, then any rational zero must be of the form p divided by q, where p are the factors of the constant term a0 and q are the factors of the leading coefficient a sub n. Let's look at our first example. In this example, we are going to find all the rational zeros of f of x, where f of x is 2x cubed plus 3x squared minus 8x plus 3, and then we'll factor f of x. Let's start by writing down f of x. Our f of x is equal to 2x cubed plus 3x squared minus 8x plus 3. And our rational zeros are equal to p divided by q. I've written down some steps that we can follow to make this easier. The first step is to find all possible values for p. Those are just the factors of our constant term. Our constant term is a sub 0, and it's equal to 3. I'll highlight that. And then p is equal to the factors of 3, and that's going to be plus or minus 1, plus or minus 3. It's always easier if you start with plus or minus 1. Now let's go to the second step. In this step, we're going to find all possible values for q, where q is the factors of our leading coefficient. Our leading coefficient a sub n is equal to 2. Let me highlight that. That's right up here. And then q contains the factors of 2, and that's going to be plus or minus 1, plus or minus 2. What we're going to do next is we're going to list out all possible values of p divided by q, because those are our possible rational zeros. Let's write down p divided by q, and that equals plus or minus 1, plus or minus 3, and then q is plus or minus 1, plus or minus 2. Now we have to see what this equals. Let's start with plus or minus 1, and if we divide that by plus or minus 1, we get plus or minus 1. Now let's go to plus or minus 3 and divide that by plus or minus 1, and we get plus or minus 3. Now we're going to divide plus or minus 1 divided by plus or minus 2. So this gives us plus or minus 1/2. And then we'll divide plus or minus 3 divided by plus or minus 2. And that's plus or minus 3 over 2. So those are our potential rational zeros. Now what we're going to do is we're going to use synthetic division to test to see if these potential zeros are roots. And if they are roots, they're going to give us a remainder of 0 when we do our synthetic division. I have a video on synthetic division if you need to review that concept. I always like to start these problems with testing out 1 first. It's just the easiest one to test. So we're going to start with a corner, and we're going to put a 1 there, because we're testing out x is equal to 1 as a possible root. And then let me pull this down. And what we're going to do is put down the coefficients that I'm highlighting up here in yellow from f of x. So our coefficients are 2, 3, minus 8, and 3. We then draw our line. We pull down our first coefficient, and that's 2. Now we can go ahead and multiply. We're going to multiply 1 times 2, and we get 2. And then we're going to add 3 plus 2 is 5. And then we're going to multiply 1 times 5, and we get 5. And then minus 8 plus 5 is minus 3. Now we multiply 1 times minus 3, and we get minus 3. And then minus 3 plus 3 is 0. We ended up with a remainder of 0, which tells us that 1 is a root of our polynomial. Because we have a cubic polynomial and we already found one root, we don't have to use synthetic division anymore because our polynomial is going to look like this. We're going to have f of x is equal to, our synthetic division told us that x is equal to 1 is a root, so that means that x minus 1 is a factor. So we're going to write that factor first. Our f of x is equal to x minus 1, and then what we have left comes from these coefficients right here. It's going to be a quadratic because we started with a cubic, so the power of 2 is 1 less than the power of 3, and this gives us 2x squared plus 5x minus 3. Now that's a quadratic, which means we can factor it. I'm going to go ahead and factor it using trial and error. We have a 2x, so let's put a 2x here, and let's put an x here. And we need to find two numbers that multiply to get minus 3. So I'm going to try minus 1 and then 3. And then let's see, that gives us 2x squared plus 6x minus x is a 5x minus 3. So that's good. Now I'm going to go up here because we're running out of room. We found that x is equal to 1 is a root. And then we have 2x minus 1 is equal to 0 is going to be a root. And that gives us x is 1/2. And then we have x plus 3 is equal to 0. And that gives us x is equal to minus 3. So we can write down that our rational zeros are equal to 1, 1/2, and minus 3. Let's go ahead and highlight our answers. Our f of x written in factored form looks like this, and our rational zeros are 1, 1/2, and minus 3. Let's do another example that's a little bit more complicated. In example 2, we have a polynomial that has a highest degree of 4. And if you just look at that polynomial, you would not know how to factor it. So this is a perfect example to do when we have to use the Rational Zeros Theorem. We're going to find the rational zeros of f of x, and then we're going to factor it. Let's start by writing down what f of x is. Our f of x is equal to 6x to the 4th minus 7x cubed minus 12x squared plus 3x plus 2. So it's long, but we can do this. We're going to start by finding all possible values for p. Those are the factors of our constant term. Our constant term, a0, is equal to 2. Let me go ahead and let's highlight that right up here. And then that tells us that p is the factors of 2, so it's going to be plus or minus 1, and then plus or minus 2. Now let's find all the possible values for q. Q is the factors of our leading coefficient, and that's a sub n is equal to 6. We'll highlight that so you can see where that comes from right there. And then we have to list out the factors of 6. We'll start with 1, so plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. Now what we're going to do is list out all possible values of p divided by q. We'll write down p divided by q is equal to, let's put down p first, plus or minus 1, plus or minus 2, and we're going to divide this by plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. It looks like we're going to get a lot of factors. Let's start by dividing our terms on the top by plus or minus 1. So that gives us plus or minus 1, plus or minus 2. Now let's go ahead and let's divide them by plus or minus 2. So this is plus or minus 1/2, and then plus or minus 1, which we already have. Now let's go ahead and divide by plus or minus 3. This gives us plus or minus 1/3, plus or minus 2/3. And then we're running out of room here, so we'll have to squish our next one in. Now we're going to divide by plus or minus 6. And that gives us plus or minus 1/6, and then plus or minus 2/6. But if we reduce that, we get plus or minus 1/3, which we already have. So we're done. That is our complete list. Now what we're going to do is use synthetic division to test our zeros and see if they give us a remainder of 0. I usually like to start with the simplest integers first and then go to the simplest fractions if we actually need to. I'm going to begin by testing x is equal to 1. So let's go ahead and let's do our corner here. We'll put 1, and we'll have to pull this back down so we can see our constants. Our constants in our f of x are 6, minus 7, minus 12, 3, and 2. We'll go ahead and draw our line. We will pull our 6 down. Now let's go ahead and let's multiply. We're going to multiply 1 times 6, and we get 6. And then we're going to add. We get minus 7 plus 6 is minus 1. Then we'll multiply 1 times minus 1, gives us minus 1. And we're going to add again. Minus 12 minus 1 is minus 13. Now we multiply 1 and minus 13, and we get minus 13. We add that, and we get minus 10. And I don't think this is going to work out. Let's keep going, though, and just make sure. 1 times minus 10 is minus 10. So we end up with a remainder of minus 8, and that is not equal to 0. So 1, we'll put an x there, is not a 0 of our polynomial. Now let's go ahead and test minus 1. I like testing 1 and minus 1 first, just because it's easier. So let's go ahead and write down our constants again. 6 minus 7, minus 12, 3, and 2. We'll draw our line and pull down our 6. Now we're all set to multiply. We're going to multiply minus 1 times 6, and we get minus 6. And then minus 7 minus 6 is minus 13. Now we multiply minus 1 times minus 13, and we get 13. Minus 12 plus 13 is 1. Now we're going to multiply minus 1 times 1, and we get minus 1. 3 minus 1 is 2. And then minus 1 times 2 gives us a minus 2. And this one's going to work out because we get a 0. This means that x is equal to minus 1 is a 0 of our polynomial. Since we found a 0, what we're going to do now is we're going to factor this 0 out and get our reduced polynomial. Let's make a note up here that this means that x is equal to minus 1, so our factor is x plus 1, because x plus 1 is equal to 0. Now we can write f of x as x plus 1. Hang with me, I know this is not easy. Now we're going to use these coefficients right here for our reduced polynomial. We started out with an x to the 4th, so now we're going to have an x cubed. So we have a 6x cubed minus 13x squared plus x plus 2. So we've made some progress, but now we have to do it again. We have to go back up here to these numbers and go ahead and test another one. We tested 1 minus 1. Now let's go ahead and let's test 2. So we'll do synthetic division, and we'll put a 2 here in our corner. And the coefficients that we're going to write down are 6 minus 13, 1, and 2. We draw our line, pull down our 6, and now we're ready to multiply. We're going to multiply 2 times 6, and we get 12. Minus 13 plus 12 is minus 1. And then 2 times minus 1 is minus 2, 1 minus 2 is minus 1, and then one more multiplication. 2 times negative 1 is going to be negative 2, and look at that. We add up and we get a 0. So that's great. That means that x is equal to 2 is a root. Now let's go ahead and let's write f of x. So we had f of x is equal to x plus 1. Now we have x is equal to 2. So this means x minus 2 is equal to 0. So this can be written as x minus 2. And then what we have left with is based on these coefficients here, and it's going to be a quadratic because this was a cubic. So we have 6x squared minus x minus 1. And that we can actually factor. So let's go ahead and let's do that. We have f of x is equal to x plus 1, x minus 2. Hang with me, we're almost done. We need to factor this one. We need the numbers right here to multiply to get negative 1. So I'm going to try 1 and minus 1. This is trial by error. And then in order to get just a minus x, we're probably going to have to use the factors of 6, which are 3 and 2. So let's see here. Let's put a 3 here just to try it. And then a 2 here. We'll put this one as a plus. So let's see, does this work? We have 6x squared. We have 2x minus 3x. So that's a minus x and then minus 1. Yay, so it works. I'm going to go ahead and highlight this. This is our polynomial written in factored form. Now we also need to find the zeros. We had 2 zeros already. We found that x was equal to minus 1, and we found that x was equal to 2. Now we're going to set this equal to 0. And that's going to give us x is equal to minus a third. And then we'll set this one equal to 0. And this gives us x is equal to 1/2. Now we can go ahead and list our rational zeros. Our rational zeros are equal to minus 1, 2, minus a third, and then 1/2. And we'll highlight those. And that's it. That's how to use the Rational Zeros Theorem to efficiently find the rational zeros of a polynomial. It's a systematic approach that turns a potentially endless search into a manageable process.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.